Hi class, this is course 3, lesson 57. Today we're talking about operations with small numbers in scientific notation. So we're going to multiply and divide in scientific notation, and the process works exactly the same as it does as scientific notation with large numbers does. We need to rewrite the problem so that we multiply the numbers times the numbers, and then the powers of 10 times the powers of 10s, or divide as needed, and then write in proper form for scientific notation. Okay, so this multiplication problem and a division problem, we're going to take 1.2 times 2, and then we're going to take 10 to the negative 5th times 10 to the negative 3rd. Okay, so I'm going to regroup so that my like items are together, and then I'm going to multiply. 1.2 times 2 is 2.4. 10 to the negative 5th times 10 to the negative 3rd is 10 to the negative 5th plus the negative 3rd. Because remember, when we have like bases and we're multiplying, we add the exponents. So this becomes 10 to the negative 8th. My coefficient here, my decimal number, is in proper form. It has one digit in front of the decimal. So I can just put these two parts together and get 2.4 times 10 to the negative 8th. Okay, let's do a division problem. Again, we divide this part and we divide this part, and we do them separately, and then we put them all together. So 8 divided by 5, remember 8 is your dividend, so it goes inside the box. Get 1, add a decimal, 1.6, that's your coefficient part. Now remember, when you're dividing like bases, that you subtract the exponent. So it's 10 to the negative 9th minus, and then put in parentheses the number that you have in the denominator. So we get 10 to the negative 9th minus the negative 5th. Okay, well, you know that when you're subtracting a negative, you really add the opposite. So we end up with 10 to the negative 9th plus 5, which would equal 10 to the negative 4th. 1.6 is in proper form. It has one decimal, or one digit in front of the decimal, so I just put those two together and I get 1.6 times 10 to the negative 4th. There's your answer there, and your answer up here. I'm going to tell you that this is probably the area that you're most prone to making mistakes, is that when you subtract a negative number, that you really are adding the opposite. So you add a positive. Okay, two more. Again, we group the numbers together. 5 times 7 is 35. And then take your powers of 10. 10 to the negative 9th plus, because we are multiplying, negative 6 equals 10 to the negative 15. So if I write this, I get 35 times 10 to the negative 15. But this is no good. It's not proper form. So we need to change this. So we need to write 35 as 3.5 times 10. So now what power do we move? This decimal, is it a positive? Is it a negative? So if I need to change from a decimal here to be out here at the end, that would be times the power of 1, 10 to the 1. So do you see how that works? I'll take this over here. If we take 3.5 times 10 to the 1st, I would move the decimal over 1, so that would give me 35. So I'm just rewriting 35 with a power of times 10 to the power of whatever. So I'm putting 35 in scientific notation in proper form. And then this part is still here, times 10 to the negative 15. So I can write 3.5 down, and then I have to fix this. So what is 10 to the first times 10 to the negative 15th? Well, you add the exponents, and you get 10 to the negative 14th power. Okay, so hopefully walking through this again, plus what you already know how to do with the positive powers of 10, it helps you, if you were having a little bit of trouble with that process, that you see it here and you go, oh, okay, you know, that makes a little more sense. Or maybe you're still confused, and if you are, please ask questions. Okay, again, the second problem here, we have division, so we need to divide 8 into 3, and I know I'll need a decimal. So 8 goes into 30. Let's see, that's 3 times. And subtract, I need to add another 0. 756. Add another 0, and I get 5. Okay, deal with the negative powers, so it's 10 to the negative 7 minus a negative 3. There again, remember that we don't subtract a negative, we add the opposite. So we end up with 10 to the negative 4th power. But this is not proper form. We need to change that. It needs to be 3.75 times. Now, which way would I move the decimal? I would have to, I'm going to take this over here, 3.75 times 10. I need to move my decimal this way. And moving the decimal to the left is a negative power of 10. So this becomes 0.375 in scientific notation is 3.75 times 10 to the negative 1st power. But I also have this times 10 to the negative 4th power. Again, I need to add the exponents when you're multiplying, so you get 3.75 times 10 to the negative 5th power. Okay, now here's a word problem for you. If a sheet of notebook paper is 1/100th of a centimeter thick, how tall is the stack of 2,500 sheets of notebook paper? Express each number in scientific notation. Okay, so there's one thing we have to do. Express each number in scientific notation and perform the calculation in scientific notation. Okay, so I need to take 0.01 and write that in scientific notation, and take 2,500 and write that in scientific notation as well. So this would be 1 times 10 to what power? If my decimal is here, and I would need to move it 1, 2, then it would be to the negative 2 power. So is that right? If my decimal goes here, 1, 2, yep. So it's 1 times 10 to the negative 2 power, and 2,500 would be 2.5 times 10 to the, let's see, I'd start here and I'd go 1, 2, 3, 10 to the 3rd. Okay, so I have 2,500 sheets of notebook paper, and each one of them is this thick, so I need to multiply these two numbers. So if I take 2.5 times 1, I get 2.5. And if I take 10 to the negative 2 times 10 to the 3rd, I add those exponents because I'm multiplying, and I get 10 to the 1st power. So my answer is 2.5 times 10 to the 1st power, or 25, if I write it in standard form, centimeters thick. Okay, so that is how you perform calculations with small numbers in scientific notation. Again, it's just an added step to a process that you already know how to do. But if you run into some trouble, please let me know. I will see you in class.